Union Pacific's Big Boy was the undisputed titan of American steam. When it was parked for good in 1959, most believed the age of steam had reached its natural end. But deep in the Appalachian coal country, another railroad refused to accept that verdict. Norfolk and Western's Y6B compound Mallet, a machine that generated over 126,000 pounds of tractive effort and burned fuel that cost the railroad almost nothing, was still hauling freight up mountain grades and beating diesel on the balance sheet. Today, almost no one remembers it. It is forgotten. If this locomotive was genuinely cheaper to run than diesel, why was it scrapped? And what does its disappearance reveal about how progress really works? The answer dismantles the accepted story of how steam died in America and exposes a truth the history books rarely tell. The best technology does not always win. Sometimes it is simply abandoned. On the high plains and mountain passes of the American West, Union Pacific's Big Boy locomotives became the standard against which every other steam engine would be judged. Each one stretched over 132 feet from coupler to coupler and weighed more than 1.2 million pounds with its tender. The 4-8-8 four-wheel arrangement, a simple articulated design with two sets of 8 driving wheels, gave the Big Boy the power to haul 3,600-ton freight trains over Sherman Hill and the Wasatch Range without helper engines. Official dynamometer tests recorded over 6,000 horsepower at the drawbar and a starting tractive effort of 135,375 pounds. 25 were built by the American Locomotive Company between 1941 and 1944. 8 survive today in museums and parks from Cheyenne to Dallas. Number 4014 has been restored to full operation by Union Pacific, drawing hundreds of thousands of spectators wherever it runs. The Big Boy's fame is unmatched. Model train companies reproduce it, coffee table books celebrate it, and its name has become shorthand for the ultimate in steam power. But by the late 1950s, even the Big Boy could not outrun the economics of diesel. Union Pacific's leadership, facing rising labor costs, expensive coal and water stops, and the growing efficiency of diesel-electric locomotives, began retiring their steam fleet. The last Big Boy made its final run in July 1959. For most people, this marked the end of the steam era. The story was simple. Diesel won, steam lost. The future had arrived. But that story was not true everywhere. 1,200 miles east of Sherman Hill, in the mountains of Virginia and West Virginia, a railroad was writing a different ending. The Norfolk and Western Railway, one of the most profitable railroads in America, was still running steam locomotives in daily revenue service, not as a nostalgic gesture, but as a calculated business decision. While every other major railroad in the country had switched to diesel by the mid-1950s, Norfolk and Western's mechanical department was producing internal cost studies that showed their steam locomotives were still cheaper to operate per ton-mile than any diesel unit on the market. The numbers were not close. On N&W's coal hauling routes, steam held a clear and measurable advantage. The locomotive at the heart of this defiance was the Y6B, a 2-8-8-2 compound Mallet articulated locomotive designed and built entirely in-house at Norfolk and Western's own Roanoke shops. It was not the biggest steam locomotive ever built. It was not the most famous, but on the ledgers that mattered, the Y6B was something no other steam engine in America could claim to be. It was profitable. Norfolk and Western's main line cut through some of the most demanding terrain in eastern North America. The Pocahontas Division, running from the coal fields of southern West Virginia to the ports and junctions of Virginia, climbed through the Appalachian Mountains on grades that tested every piece of equipment the railroad owned. The challenge was not just steep hills, it was the sheer weight of the trains. N&W hauled more coal than any other railroad in the country, and every ton had to be dragged over the mountains to reach market. The railroad needed a locomotive that could move enormous loads reliably, day after day, at the lowest possible cost. The answer came from Roanoke. Norfolk and Western was one of the last American railroads to maintain a full-scale locomotive manufacturing facility, and the Roanoke shops became the birthplace of some of the most refined steam designs ever produced. The Y6 class, first introduced in 1936 and progressively improved through the Y6A and Y6B variants, represented the peak of compound mallet technology in North America. The final Y6B units, completed between 1948 and 1952, incorporated decades of operational feedback and engineering refinement. Every bolt and bearing reflected lessons learned on the mountain. The compound mallet principle was the key to the Y6B's efficiency. Unlike Big Boy's simple expansion system, where high-pressure steam entered each cylinder once and then exhausted, the Y6B used its steam twice. Superheated steam from the boiler first entered a pair of high-pressure cylinders, each 25 inches in diameter with a 32-inch stroke. After doing its initial work, the partially expanded steam was routed to a pair of much larger low-pressure cylinders, 39 inches in diameter, where it expanded again to extract a second round of energy before exhausting up the stack. This two-stage process wrung more work from every pound of coal, a crucial advantage on a railroad where fuel cost was already low and every percentage point of efficiency translated directly into profit. The boiler operated at 300 pounds per square inch, feeding the compound cycle with a steady supply of superheated steam. Driving wheels measured 58 inches in diameter, smaller than Big Boy's 68-inch drivers, but ideally suited for the slow, relentless pulls that defined Appalachian coal service. The locomotive's weight, over 573,000 pounds on its drivers alone, pressed down on 16 driving wheels, giving the Y6B the adhesion it needed to start and move trains that stretched for a mile or more through mountain hollows. Starting tractive effort in compound mode reached over 126,000 pounds. When operating in simple expansion for starting heavy loads, that figure climbed higher still, rivaling or exceeding Big Boy's celebrated 135,375 pounds. But the Y6B's technical edge was only part of the story. Norfolk and Western's economic advantage over diesel rested on a set of circumstances that no other railroad in the country could replicate. First, fuel. Norfolk and Western hauled its own coal. The locomotive's firebox burned the same bituminous coal that filled the hoppers trailing behind it. The cost of fuel was not a line item purchased from an oil company. It was a byproduct of the railroad's core business, available at pennies per ton. Diesel locomotives, by contrast, ran on petroleum, a fuel that had to be bought at market prices, delivered by tanker, and stored in dedicated facilities along the line. Second, manufacturing. Every other railroad purchased its locomotives from outside builders like Alco, Baldwin, and MD, but Norfolk and Western designed and built its own. The Roanoke shops employed thousands of skilled machinists, boilermakers, and engineers who could fabricate a locomotive from raw steel to finished product without depending on external suppliers. This vertical integration slashed procurement costs and gave the N&W's mechanical department the freedom to refine and improve their designs in ways that off-the-shelf diesel builders could not match. Third, maintenance. N&W's steam fleet was maintained to a standard that rivaled any railroad in the world. Shop crews at Roanoke and the division shops along the main line had spent decades perfecting the routines for servicing Y6 class mallets. Every procedure was optimized, every tool was in place, every worker knew the machine inside and out. Turnaround times were fast, availability rates were high. In internal cost analyses of the early 1950s, N&W's mechanical department documented that their Y6B locomotives cost less per revenue ton-mile to operate than the diesel units being tested on the property. The advantage was not a rounding error. It was significant enough to delay dieselization by years, while the rest of the industry rushed headlong into the new era. On the Pocahontas division, the Y6B proved its numbers in the most demanding conditions American railroading could offer. Crews assembled coal trains stretching over a mile, each one weighing 10,000 tons or more, and pointed them toward the mountains. The Y6B took the throttle and climbed, its compound cylinders hammering in sequence, exhaust barking against the mountainside. Engineers who ran them described the sensation as relentless, a locomotive that did not surge or falter, but simply pulled, mile after mile, grade after grade, through